Okay, here's a question about an inclined plane from June 2014. So we've got a crater, we know the mass, we know it's on a rough slope, so there's going to be some friction, we know the angle of inclination, and it's the coefficient of friction that I'm going to have to find, and I'm given that it's on the point of slipping. Okay, so first thing we need to do is get all the forces on. So there will always be a weight even if it's not touching anything. mg for the weight is going to be 40g. Okay, what else? What is touching it? Well, just the surface. So we're just going to have a normal reaction. So there's a force at right angles to the surface. I'm going to call that R for reaction. And because it's a rough slope, we can have some friction. And friction will always stop it from slipping. So it would slip down. So friction opposes that. So the frictional force will act this way. So those are my three forces, and I'm going to be resolving them. Okay, but because it's at rest, it's not accelerating, the total of my three forces is going to be 0, 0. So I need to set up my three forces, and when we're resolving in this situation, we always go up the slope and perpendicular to the slope with my x and y directions. So two of the forces are easy, R and F are pointing in the x and y directions. And in fact, I can see there in the positive x and the positive y directions, F is up and R is away. Okay, now the weight needs resolving. I can see that it's acting actually in the negative x and the negative y directions, so they're both going to be negative. Okay, and obviously the angle is going to be 30 degrees. And obviously the size of that force is 40g, so 40g in each slot. Okay, now what I've got to do is get the sine and the cos the right way round. Now, because it's on a slippery slope, we're coming in with an expectation, but we should do it properly. We should find the 30-degree angle. Here it is. That's the 30-degree angle. I haven't got room to put the 30 degrees on, but I can see the 40g force makes a 30-degree angle. It cuddles up to this direction, which is the y direction. So therefore, it's the y that gets the cos. So as we might have expected, the first one is a sine. So that is my force equation for the first part, okay? And I need to use that. Well, I can find R from the bottom row, I can find F from the top row, and then F is related to R because it's on the point of slipping, and I can use the third equation. It's going to be the one with mu in, okay? But let's start by finding F and R from the X and Y parts. So just looking at the x line, I've got f minus 40g sine 30 degrees equals 0. I should say equals 0 on there. So f is going to equal 40g sine 30 degrees. So f equals 40 times 9.8 times sine 30 degrees. Do that on your calculator, you actually get 196 newtons. Okay, and similarly, when you do r, we're going to add the 40g cos 30 degrees to the other side. So you're going to get r equals 40g times cos of 30 degrees, which actually gives you 339.5 newtons when you do those on your calculator. So your F and R drop out straight away. Now it is on the point of slipping, so it is about to slip. So about to slip means that the friction will be its maximum value, which is mu times R. So if F equals mu R, then mu is going to be the F divided by the R, and I've got F here is 196 divided by the 339.5, and if you do that on your calculator, you get 0.5774. I could probably get away with just three significant figures, but I think I'm going to be using that mu later on, so saving a bit more accuracy will be useful. So that's part A. In part B, it's a similar situation, but now I've got an extra force acting. Okay, and now it is accelerating, and it's accelerating up the slope. So it's slipping. So I'm going to have limiting friction again. Friction will do everything it can to stop it accelerating. But because it's accelerating up the slope with a 0.2 acceleration, okay, friction will now be acting backwards. Okay, we'll still have a normal reaction force R, and we'll still have the 40g weight. And the nicest thing is that the 40g is still going to be resolved in exactly the same way. So is R. F is just the reverse of what it was before. So my first three forces are going to be fairly straightforward. There they are. This third one is just exactly the same as we discussed earlier. Okay, this one is going to be for this force X. Okay, now unfortunately X is going to need resolving, so we'll come to that. And also we've got acceleration, so instead of equaling 0, 0, we're using resultant force equals mass times the acceleration. Okay, alright, I could have put the mass in, the mass is actually 40, and I also know the acceleration. The acceleration is 0.2, but I also know the direction, it's going up the slope. So it's 0.2 in the X direction and nothing in the Y direction. Okay, so let's fill in this unresolved force. So X is acting at an angle, so I need to find the 30-degree angle. So this is actually quite an easy 30 degrees to find. So I can see that X is coming in the positive X direction, the negative Y direction, okay, and the 30 degrees is the angle with the X direction. So remember my axes are like this, X and Y. So it's going to be the X this time that gets the cos 30 degrees. So we're going to have, okay, X cos of 30 degrees in the X direction and minus X sine of 30 degrees in the Y direction. So that is my equation, all right? So in B part 1, I had to find the normal reaction in terms of X. So my normal reaction is here. So that shows I'm going to be using the bottom line. So my Y direction implies that R minus 40g cos of 30 degrees minus X sine of 30 degrees equals 0. So make R the subject. R equals, well, I can do 40g cos of 30 degrees on my calculator. Actually, I've done that calculation before. That is 339.5, but that's not the final answer for R this time, because adding this sine of 30 degrees is 0.5, so plus 0.5 x. So I've got my expression for R, okay, and now, so that's my answer to B1. B dotty 2, I've now got to use the acceleration to find out what x is. Okay, well, if I want to get the acceleration of 0.2 into it, I have to be using the top line of what I've written. So that's telling me that minus f, okay, minus 40g sine of 30 degrees plus x times cos of 30 degrees equals m. Now m is 40 times 0.2. All right, now how's that helping? I want to find this x, but now I've got this f in it. Well, f is still related to r because it's actually slipping, so it's still true that f equals f max because it's slipping, and that equals mu r. And from the previous part of the question, I know what mu is. So for this minus f, I can put minus, because it's minus, and then mu times r. Okay, but r is this stuff here, 339.5 plus 0.5x. Okay, so that's my minus f term. Minus 40g sine of 30 degrees, I've done before, it's minus 196. Plus x cos of 30 degrees is, well, cos of 30 degrees is 0.8660 times x equals, and 40 times 0.2 is 8. So this is a bit of a messy equation, okay? Mu is not unknown, mu is this number here. So I have to multiply 0.5774 by 339.5, and lo and behold, that actually gives me another minus 196, okay? Minus my mu, which is this, times 0.5x is going to give me minus 0.2887x, because this is just half of the 0.5774. Okay, minus another 196. Okay, plus 0.8660x equals 8. So gathering my x terms, I've got this many minus this many. That actually is 0.5774x equals, and then I've got two lots of 196 to add to both sides, and that turns out to equal, when I add it all up, exactly 400. 8 plus 196 plus another 196 is 400. So to finish this question off, I just need to do x equals 400 divided by the 0.5774, which equals 692.76. Well, 3 significant figures is all I need, so that is 693 newtons, and I'm done. So the algebra is a very simple equation, but it's got messy decimals in it, which makes it slightly frustrating. But we're there, so we finished that question.